Look up. Right now, wherever you are, look at the sky. It's blue. Not purple. Not green. Not black. Blue. But here's the strange part, space isn't blue. The sun isn't blue. Air isn't blue. So why is the sky blue? Is it painted that way? Is it reflecting the ocean? Or is something invisible happening above your head every single second? Today, on Simple Things, Why and How, we're uncovering one of the biggest everyday mysteries hiding in plain sight. At first glance, the answer seems simple. We're taught it in school. The sky is blue because of light scattering. But what does that actually mean? To understand this, we need to start with sunlight. Sunlight looks white. But white light is actually a mixture of all colors: red, orange, yellow, green, blue, indigo, and violet. When sunlight travels through space, it moves in a straight line. No problem. But when it enters Earth's atmosphere, everything changes. Because now, it has to pass through air. And air, even though we can't see it, is full of tiny particles: oxygen, nitrogen, dust, water vapor. These particles are incredibly small. Small enough to change the path of light itself. Here's the key idea: different colors of light have different wavelengths. Red light has a longer wavelength. Blue light has a shorter wavelength. And shorter wavelengths are scattered more easily when they hit tiny particles. Imagine throwing a long rope through a forest versus throwing a handful of tiny beads. The rope moves through easily. The beads bounce everywhere. Blue light is like the beads. When sunlight hits the atmosphere, the blue light gets scattered in all directions by the tiny air molecules. Red light? It mostly continues straight. So when you look up at the sky, you're not seeing the sun directly. You're seeing scattered blue light coming at you from every direction. That scattered blue light fills the sky. And that's why it looks blue. But here's something interesting. If blue light scatters more than any other color, then why isn't the sky violet? Violet actually has an even shorter wavelength than blue. So technically, violet should scatter even more. So why don't we see a violet sky? 2 reasons. First, our eyes are more sensitive to blue than violet. Second, sunlight actually contains less violet light compared to blue. So even though violet scatters strongly, there just isn't enough of it, and our eyes aren't very good at detecting it. The result? Blue wins. Now let's take this further. If the sky is blue because blue light scatters, why does the sky turn red, orange, and pink during sunset? At sunset, the sun is lower on the horizon. That means sunlight has to travel through much more atmosphere before reaching your eyes. As it travels that longer path, most of the blue light gets scattered away before it reaches you. What's left? The longer wavelengths, red and orange. That's why sunsets glow with warm colors. It's not that the sky changes color. It's that the blue light has already been scattered out of your line of sight. Now here's something even more fascinating. If Earth didn't have an atmosphere, the sky would be black. Even during the day. Astronauts on the moon see a black sky because there's no air to scatter light. The blue sky is proof that we have an atmosphere. It's proof that tiny invisible molecules are constantly interacting with sunlight above us. Every time you look up and see blue, you're seeing physics in action. You're seeing light collide with matter. You're seeing the atmosphere reveal itself. The sky isn't painted. It isn't reflecting the ocean. It's a result of invisible particles, microscopic interactions, and the physics of light. Something so ordinary. Something we see every day. And yet, it's one of the most beautiful scientific phenomena happening above us at all times. That's the power of simple things. They look ordinary. Until you ask why. If you enjoyed discovering why the sky is blue, there are thousands more everyday mysteries waiting to be uncovered. This is just the beginning. Subscribe to Simple Things Why and How. See you on the next one.